In the vast silence of space, beyond the warmth of our sun, drift worlds untouched by mankind. Planets that orbit distant stars, hidden in the cosmic sea, waiting to be found. They do not whisper, nor shine like their suns, yet they hold secrets that echo our deepest questions. Are we alone? Or are these distant orbs the mirrors of our own beginnings? Some are scorched. Others are frozen. But a rare few sit just right. Not too hot, not too cold. With the promise, however faint, of oceans, skies, and life. This is the search for Earth's twin. A quest not just of science, but of destiny. Welcome to the top 10 most potentially habitable exoplanets ever discovered. Kepler 62f is an exoplanet about 1,200 light-years away in the constellation Lyra, orbiting within the habitable zone of a K-type star. It is roughly 1.4 times the size of Earth, indicating a likely rocky composition. The planet receives about 41% of the sunlight Earth does, suggesting it could be cooler but still able to support liquid water with a suitable atmosphere. Its orbital period is approximately 267 days. Kepler 62f star is less active than many red dwarfs, which benefits atmospheric retention. Although no atmosphere or surface conditions have been directly observed, climate models suggest the planet could maintain habitable temperatures. It was discovered by the Kepler mission in 2013, adding to the growing list of potential Earth-like worlds. Kepler 62f's location and size make it a key target for understanding planet habitability in different stellar environments. K218b orbits a red dwarf star approximately 124 light-years away in the Leo constellation. It is a super-Earth about 2.7 times Earth's radius and 8.6 times its mass, placing it between Earth and Neptune in size. K218b is within the habitable zone, and in 2019, water vapor was detected in its atmosphere, making it the first habitable zone exoplanet with confirmed water vapor. However, the planet's atmosphere is thick and could be more like a mini Neptune than a true rocky planet, raising questions about surface conditions. Its potential habitability depends heavily on atmospheric composition and pressure. Ongoing observations aim to understand if it has a solid surface and if conditions could support life. The planet's discovery boosted interest in super-Earths with atmospheres containing water vapor. K218b remains a priority target for future telescopes to clarify its true habitability status. Wolf 1061c is a super-Earth orbiting the red dwarf Wolf 1061, about 14 light-years from Earth in the constellation Ophiuchus. It has an estimated mass 4.3 times that of Earth and lies in the middle of its star's habitable zone. The planet completes an orbit every 17.9 days, receiving stellar radiation comparable to Earth's. Its host star is relatively inactive, lowering the risk of atmospheric erosion from flares. The planet's size and location suggest it may have a rocky surface and could support liquid water. Discovered in 2015 via the radial velocity method, it remains a strong candidate for future observations targeting biosignatures or atmospheres. GJ667cc is a super-Earth orbiting one of the stars in the GJ667 triple star system, about 23.6 light-years away in the constellation Scorpius. It has around 4.5 times Earth's mass and lies in the habitable zone of the system's primary M dwarf star. The planet's orbit period is about 28 days, placing it within a temperature range that could support liquid water. Though part of a multi-star system, the environment may still permit stable conditions for life. GJ667cc's host star is relatively quiet, reducing stellar flare risks. Discovered in 2011, it was one of the earliest known habitable zone super-Earths. Its potential rocky composition and stable orbit make it a compelling target in the ongoing search for life beyond Earth. Teegarden star B orbits a red dwarf located roughly 12 light-years from Earth. Discovered in 2019, it is one of two Earth-sized planets in the star's habitable zone. With a mass very close to Earth's, it completes an orbit every 4.9 days. Despite the short orbit, the star's low luminosity means the planet receives similar energy to Earth. Its host star is known for low stellar activity, improving the chances of atmospheric retention. Teegarden's star B's mass and potential temperature make it a strong candidate for habitability. Its proximity allows for more detailed observations than many other targets. Though its atmosphere remains unconfirmed, it is one of the most promising nearby Earth analogs. Ross 128b is a temperate exoplanet orbiting the red dwarf Ross 128, about 11 light-years from Earth in the constellation Virgo. With a minimum mass close to Earth's, it orbits within the habitable zone of a relatively quiet star that emits fewer flares than typical red dwarfs. Discovered in 2017, it completes an orbit every 9.9 days, but its star's low luminosity keeps the planet within a potentially life-supporting range. Its proximity and calm stellar environment make it a promising target for future atmospheric studies. While no atmosphere has been confirmed, Ross 128b may support a stable climate and the conditions necessary for life. Kepler 442b is an exoplanet about 1,200 light-years away in the constellation Lyra, discovered by the Kepler Space Telescope. About 1.3 times the size of Earth, it orbits within the habitable zone of a stable K-type orange dwarf star. The planet likely has a rocky surface and receives around 70% of Earth's sunlight, suggesting cooler but potentially habitable conditions. Though no atmosphere has been directly observed, models suggest it may sustain one that protects surface life. Its 112-day orbit keeps it well within habitable limits. Despite its distance, Kepler 442b remains one of the most promising habitable candidates found by Kepler. LHS 1140b is a super-Earth orbiting a red dwarf star about 40 light-years away in the constellation Cetus. With a mass 6.6 times that of Earth and a radius 1.7 times larger, it likely has a dense, rocky composition. It lies within the star's habitable zone, where liquid water could exist. The relatively quiet host star increases its chances of retaining an atmosphere. Discovered in 2017, it's a prime target for atmospheric studies to detect gases like oxygen or methane. Its longer orbit gives it moderate stellar radiation, and stronger gravity may impact future colonization. Despite limited data, it remains one of the most promising nearby super-Earths. TRAPPIST-1e is one of 7 Earth-sized planets orbiting the ultra-cool dwarf star TRAPPIST-1, about 40 light-years away. It lies in the habitable zone, making it a prime candidate for liquid surface water. Its size and density are similar to Earth, indicating a rocky composition. The planets are tidally locked, with one side always facing the star, which affects climate patterns. Despite this, TRAPPIST-1e is considered the most Earth-like, with moderate temperatures and potential for habitability. Possible atmospheres have been detected around some TRAPPIST-1 planets, though their exact makeup is unknown. TRAPPIST-1e is a major target for telescopes like the James Webb Space Telescope, which may reveal signs of water or life. Proxima Centauri b orbits Proxima Centauri, the closest star to our Sun, at 4.24 light-years away. It is an Earth-sized exoplanet in the star's habitable zone, where temperatures may allow liquid water. Proxima Centauri is a red dwarf, dimmer than the Sun but prone to flares that could strip a planet's atmosphere. Despite this, Proxima b is a strong habitability candidate due to its size and proximity. Its mass is about 1.17 times Earth's, suggesting a rocky world. However, intense radiation and possible tidal locking pose major challenges for sustaining life. Scientists continue studying it for atmospheric clues and biosignatures. Its discovery in 2016 was a major step in finding nearby habitable worlds. These 10 planets, and many more out there yet to be discovered, are more than distant worlds. They are reflections of our hopes, echoes of our questions, and windows into what might be possible beyond Earth. Each one challenges what we know, teasing us with the idea that life might not be unique to our small blue world. Somewhere, there could be alien winds, unfamiliar oceans, or even life gazing back at the stars. But as we look outward, we are also reminded of something deeper. Earth is still the only home we truly have. These exoplanets ignite our curiosity, but they also highlight our responsibility. The journey to reach them may span centuries, or remain beyond our grasp. Yet the search drives science forward, uniting astronomers, engineers, and dreamers under one sky. In exploring other worlds, we rediscover our own. And that is the real meaning of this cosmic quest. If you enjoyed this journey through the stars, don't forget to like this video and subscribe for more discoveries across space, science, and beyond.